Okay, transformer questions. Transformer questions, use the transformer equation. So there is nothing else that you need to overthink here. Don't think about flux or anything like that unless the question is a little bit more in depth and is actually asking you to explain the operation of a transformer. So all we've got to do is figure out numbers of turns and stuff. So what do we know? So we've got the number of, we want to find the number of turns in the primary coil. So that's the first thing. So it says turns required in the primary coil. Okay, the secondary coil has 600 turns. It's written right there. Now, it's required to step down 5,000 to 240. Now, if a question's written like that, they're telling you that this is the primary and this is the secondary. So if a transformer is stepping down, then the input is higher than the output. If it's stepping up, then the opposite thing is happening. So this is a way you can figure out which is which. So we've got VP equals 5,000 and volts, and VS is 240 volts. Now, when we have a look at the, actually filling in this answer, all we've got to do is substitute this into our formula. Now remember that this one is on the formula sheet, and what you find with this one is that they're just proportional to each other. So you've got NP over NS just equals VP over VS. This might be the inverse of what's written in the formula sheet, but it's the same thing, so it really doesn't matter. So we're going to have NP equals 600 over 600 is 5,000 over 240. Now we're just going to rearrange this by multiplying the 600 across. And we end up with 12,500. Now, if you think about all the information I've given you, it's all got three significant figures, so we can actually put in 1 to 500, where the first three are our significant figures here, so round to the third figure. Calculate the peak voltage in the high voltage power line referred to in question 12. Well, the highest voltage in question 12 is 5,000, so we've got to use that one. So we just multiply that by root 2 to get a peak voltage, and so we get, what's that, 7,000, I think it's like something like 7070. Now again, we've still got, in fact, we've got a whole lot of significant figures here if you're assuming that these are all significant. So, in fact, you could probably put in 7071, I think would be the right number there, and that would be a reasonable answer. A transformer supplies a total current of 1200 amps at 240 volts. What is the input current? Now, I haven't given you all the information in this bit, but some of the question is in the previous parts. We're talking about the same transformer. So what have we got? We've got the primary voltage is 5,000. We've got the secondary voltage is 240. We've got now the 1200 amps is at 240 volts, means that this must be the secondary current, 1200 amps. Which means we want to know, the primary current. Now, if we write the equation here, now this is not on the formula sheet, but it's actually pretty easy to remember anyway if you don't have it. They're just inversely proportional to each other. So the IP over IS equals VS over VP. So then we just substitute this in. So we've got IP over 1200 equals 240 over 5,000. Now you rearrange that and you get that your current in your primary circuit was 58 amps. Now remember that this should make sense, because when we have high voltages, we're doing that so that we can transmit low currents. You're always going to have a low current in the high voltage side of your transformer and a high current in the low voltage side. Okay, last question. Now this was a thinking question. You had to think about this to answer it well. Now it's about physical principles. So what are the physical principles we've been talking about? Faraday's law that induction can only happen if there is a change in flux over change in time. Now, why can DC not be transformed? Now, in terms of these principles, actually I'm just going to write down that, Faraday's law. Sorry, having trouble writing this morning. DC does not produce change in flux. Full stop. Okay, AC. Now, AC does produce a change in flux, so is able to be transformed. So that's the first part of that question. But if you just say AC can be transformed, you're not actually referring to any physical principles at all. You're just saying something that we learned last year. But if you say it can be transformed because it produces a change in flux, then you're linking that to Faraday's law. Okay, so it can, then we can say that it can be stepped up to high voltage with low transmission current. Now, then we can say that there is low power loss or lower power loss, and I would link that to P equals I squared R, and in particular that as the as the transmission current decreases, the power is going to decrease in proportion to the square of that. Okay, hopefully these are good. Feel free to email me if you've got any other questions, and we'll go over this more on Tuesday.